who is my friend and his colleague. As part of the course requirement on the introduction to deep learning, we are required to implement a project, so for which we have chosen video summarizations. The course is conducted by Dr. Arjit Mandal, Assistant Professor IIT Patna, and in his able guidance, we are doing this project. So, in terms of agenda, we'll try to cover why we need video summarization, what are different applications of video summarization. Then we'll introduce the various classes of video summarization techniques. Then we have picked uh, one of the algorithm called DSNet, for which we have tried to replicate results, and we are able to replicate results for the same. So we'll discuss about the same, and towards end we'll discuss the results of DSS which we were able to replicate. Okay. So video summarization is nothing but the process to generate a short summary of the content of a longer video document by selecting and presenting the most informative and interesting material available in the video. Video summarization can be used in various real-life scenarios, like let's say video surveillance, video synopsis. Uh, you know, let's say there are many large videos to access, and if you want to search information quickly, in that case also video summarization can be very helpful. It can be helpful in organizing the document, indexing the of video, and let's say typically the content recommendation works around uh, the title of videos or the tags. Generally the people who create those videos provide, but then inside the video, what is the content might be more important than the title itself, and hence video summarization can be a very powerful tool in doing content recommendation on actual content as well. So moving on, so at the high level, video summarization is, involves uh, short selection, so the and then followed by frame level, importance, uh, you know, prediction or importance score calculation, and then key sort selection based on the various approaches in terms of whether level is provided or not beforehand. Broad classification of video summarization technique can be completely unsupervised where level is not provided, then weakly supervised where partial information is available, and then supervised algorithms. Now I would hand over it to Lucky to walk us through various techniques and architecture of DSNet approach. Over to you.
So here we have a different. Thank you, Krishna. So now I am going to see the and explain the different categories of video summarization. So initially, and which is more popular categories initially was the unsupervised and the weakly supervised, and then whatever we are doing in our project work, that is supervised. So in unsupervised and weakly supervised, we are having different uh, papers, and we have in the reference of uh, this work. Uh, so in this method, actually heuristic criteria like representativeness, diversity, and sparsity is included. So these have uh, different methodologies to incorporate uh, this category. So first is the clustering based and dictionary based and the substance selection based, reinforcement learning based, adversarial learning based. These are the categories in the unsupervised learning. And the weakly supervised process, uh, just three informations were being used, like web priority, video titles, and video categories. And mostly the in these techniques, in these categories, most most of the part which every categories does is they first choose the web priority and the video titles, and then they categorize the videos. But the problem with these methods are and they are not learning based, so they cannot learn with the uh, past categories. uh, in the supervised uh, categories, in the supervised method, actually we will handle the problems which were occurring in the unsupervised and the weakly supervised models. So in the supervised methods, we have direct sequential subset selections, video summarization with long short-term memory, and the retrospective encoders, attention-based encoder-decoder networks, user ranking, video summarization. These are the different processes in the supervised method. So, the important thing which we are including in this supervised method is the temporal consistency constants. So which are lacking in the previous methods, like in the super unsupervised and the weakly supervised. So what we do in the temporal consistency constants, that we generate a temporal interest proposals with the predefined multi-scale interval. Suppose we are having a uh, video V, and we just divide into the T multiple frames, and we keep the same probability of each frame, which makes the proposal generation strategy of the temporal variant. And we provide those frames a positive or negative uh, binary proposals, and thereafter we provide a suitable ratio to avoid the class imbalance problem. Suppose we are having a ratio of 1 is to 3, so we divide these binary classes into the 1 is to 3 uh, ratio, and thereafter we apply the desired approach uh, to get the summarization done. So for the uh, to frame all of our the approaches, we are having a DSNet framework we have proposed. Not we have proposed, actually that is proposed in the paper. So, and direct to summarize network uses two main things. First is the temporal interest detection process, which I have explained earlier, and the secondly, it is including simultaneously it will predict the important scores and their location, so it can be easily for the user to uh, to avoid the actually the problems which are coming in the uh, previous models. So it will avoid to get the overfitted model. So now the DSNet approach will have two different approaches: anchor based and the anchor free approach. So in the anchor based approach, we have uh, it produces actually interest proposal at each temporal locations with multi-scale duration handling and the length of the variation of interacts. So and actually and after that it does eliminates the temporal proportions and avoid complicated computations, such as it is having so many intersections and the unions. So it will avoid those things, and thereafter it will go to conduct the keysort selection to summarize to the final step of your video summarization. And the anchor free approach, we directly predicts that what is the important score of our video, and then centerness the score, and then the 2D temporal locations vector at each temporal locations, and thereafter we directly do the keysort selections. So this approach mainly concerned with the two steps. First is the feature selection. Feature selections is like what we have seen, that the prediction of an important score, and thereafter they will do the keysort selection. And in the anchor based approach, we are having uh, three processes. First is the feature extraction, thereafter the temporal interest proposals, what we have divided our video into the uh, multiple frames, suppose 3 frames, and thereafter uh, we do the uh, proposal classification and the regression, and this and in the anchor free approach we removes this problem, actually this process of classification and the regression. So the algorithm for these two approaches are shown here. So first is for the anchor based approach, and the another is for the anchor free. कुछ वीडियो आ गया था बीच में. हेलो. So so in this algorithm we first take the video v, and we take the t shots, t different frames of the video, and thereafter we apply the Google Net, and and each loop actually we extract some features. So we initially extract two types of features. First is the long range representation, and another is the original spatial features, and we and at the end we combine with those two long range representation and the original spatial features, and finally we go for the classification and the regression, and thereafter the keys we apply the key sort. And in the algorithm 2, which is training process of the anchor free based approach, here we just divide video into the number of frames, and thereafter we extract that the temporal features, which are a long range representation and the original spatial features. We combine them, and thereafter we just do the uh, key sort selections, and we don't go for the classification and the regression, and we must we not actually keep force on those processes. So these are the differences between the two approach. Next, so the architecture for the DSNet is shown here, where we are providing some video, and then we do the feature extraction, and thereafter we uh, propose uh, the temporal interest proposal, and thereafter the classification and the regression, and thereafter the keysort selection process will be done. So in the feature extraction, the long range temporal information, which provides high level understanding of the videos. So first we employ Google Net to extract feature vectors Vij, and these are the vectors which will frame your videos into uh, different segments, and then we extract the long range representation WD and then WT, and then we add those long range representation, range representation and the original spatial features. We add both of them, and in the temporal interest proposals, we take the different groups of the videos, and and we channelize them according to the their temporal scores to the different locations. And next, for the classification, the default detailed components of classification and the regression module. In this, what we do first, we do the parallel components into the linears, and then we apply the process 10H and the dropout, and thereafter we provide some offsets, and then thereafter we classify the important segment scores separately. Next, and these are the uh, results which we have got after running both the approaches. So now we are going to show it on Google Colab. So now I am moving to the Mr. Krishnamohan Rai.
Yeah, sorry. So yeah, so we we were able to replicate results of the original paper. So more or less, it was coming same up to four digit. So not to two digit here because we have multiplied it by 100. Uh, you know, there might be that error because of that approximation. For replicating this result, we kind of used Google Colabs because it was taking time, so we used kind of locally installed Python instance as well to run these modules. Uh, one thing which we were not able to do apple to apple comparison was the time performance with the paper because uh, the paper in paper author is talking about time on GPU based system. However, we have used CPU based system and it was taking too much time and hence we were not able to do that exact comparison. So now I will just walk you through the results. So these are the results that were reported by author in his model. So for TV some data diversity of 0.47 or 47.63, an FS score of 62.05, and for us we were able to get diversity of 47.48 and FS score of 61.79. Similarly, for some data set, author was getting 64.24 and FS score of 50.19. However, we were able to get diversity score of 64.34 and FS score of 50.76. Uh, Similarly, for anchor-free base approach, up to four digit, actually, we were able to so for let's say TV sum data, so author was getting diversity a score of 47.65 an FS score of 61.86. However, we were able to get 47.32 and FS score of 61.68. More or less similar result. There was small difference, and that difference may be because of the seed that was used to train this model by author versus in our system. However, the results, the difference in results is very minute and can be ignored. Similarly, for summary data for anchor-free best model, author was getting diversity a score of 66.41 and FS score of 51.18. Uh, and we were able to basically get exact result in this case, which was diversity of 66.41 and FS score of 0.5118. So more or less we were able to replicate the result proposed in the paper. Um, I mean the minute difference, you know, to let's say third or fourth, first or second decimal point was maybe because of system variance, but otherwise we were able to replicate it. In terms of future work, we are not able to do much in this project. However, we are planning to kind of combine various approaches and see if we are able to improve results. Uh, we kind of also try to play around with activation functions and various randomization algorithms. However, we are not able to see any improvement, and hence we'll try other approaches to see if we are able to improve results compared to what author has proposed. So that's all from our side. I know before we conclude, we would like to thank our instructor and mentor, Dr. Rajit Mandal, for his support and providing his topics and kind of motivating us to work on these projects. So thanks everyone for watching. Bye bye.